guy. I'm not even sure whose plot this is, but anyway, here we got some 3D objects, right? A Rubik's cubes there and some stuff, right? But like, look, there's a hypercube here, and from this perspective, it looks like that hypercube is built with blocks in 3D, right? And then as we look at it, it's like, actually no, it's a four-dimensional object projected onto a two-dimensional surface that looks three-dimensional. Okay, right? So if we're viewing a 4D object in 2D space, we're seeing a much compressed version. It's hard to explain. You're not seeing all the states that it could be in. Like in a three-dimensional object, you can fly around three dimensions here and see all the sides of this three-dimensional object, right? But if you have a four-dimensional object projected into 3D, then you're only being projected one current side of it, if that makes sense. One current slice, I guess, would be a better way to explain it. And then that slice can move through 3D space. So you would need a bunch of continuously changing statues in a row, one after the other, and then you'd have to like be able to see all sides of each one at once, and that's your 4D object, right? But it doesn't really work like that. So up here is a massive multi-dimensional hypercube, right? So I didn't build this. This is somebody else's. I'm not trying to take credit for this. I just want to explain some of this because it's kind of cool, right? So here we see a hypercube. We see this black box here and this black box here. So these are standard cubes, right? The black boxes are cubes. But then we have hypercubes, which are how these black boxes are connected to each other. So this one has to connect here to here. Oops. And likewise, the yellow does so here. The yellow connects it up there. So the yellow is the connecting lines from 3D to four-dimensional objects. So let's just pretend nothing else is here, and let's just look at this. This is showing us a four-dimensional object projected into 3D space. We are only seeing one side of it. Even though we're able to rotate around this is one side or one state or one slice of the actual thing, because we don't have four dimensions to actually build in. Alright, but we can still, this is like a shadow of that object. Just like we were able to do a shadow of a 3D object on a 2D surface, and we're able to even put a 4D object that looks like on a 2D surface. Here's a 3-dimensional 4D object, and then we make that 5-dimensional by connecting the black boxes to each other with what looks like the blue lines. The blue lines are doing the 4D to 5D projections. Alright, so we're doing, and then these rectangles that get formed here, they're not rectangles, they're rectangular bricks, I guess, like blocks that get formed by these blue lines here, that get formed up and down by each one. Then those are each their own four-dimensional line connecting a 5-dimensional shape, right? So then this just keeps expanding outwards, and I don't even know what this goes to, but I figured you guys might appreciate this, just the fact that somebody took the time to build this and show us what a projection looks like. And there's one more neat aspect. So for those of you that have seen the movie Interstellar, right? Remember the scene where that guy goes into like the bookcase, like he's in the black hole, but he's in the bookcase, but the way he moves is like very odd, right? That's because it includes time as one of the spatial dimensions. And so when time is included as a spatial dimension, you see we're kind of limited where we can go here, but like there's a clear path diagonally right there. We can move diagonally like this, and then we can move diagonally upwards like this. But we can't really move like this. See, like this is indicating a wall. But then this is how we get to the next biggest space. And so this is like what I forget the name of the character of the guy, but this is why he's moving in that way. It's as if time is included as a spatial dimension. So it's kind of trippy. It's kind of cool to think about. It's just a mathematical model. That's really all it's used for, is modeling the universe. And here's one more thing I'd like to say about models, right? If the model isn't actually how the universe works, but the model predicts accurately, then the model's job is still fulfilled. You know, for a while Newton's laws worked for small scale things, right? But then on like some larger scales, like the orbit of Mercury, it didn't work. Newton wasn't wrong, right? His theory was just undeveloped compared to somebody else with a different explanation. So just his theory worked for a while, but there's always something better, right? So that's just my note on that. We can always improve, but a theory means it does work currently. Don't take that as like, oh, it's just a theory, therefore it may not be true. No, it's a very rigorous, tested thing by a scientific community. And so for anybody that spouts those words like, oh, it's no big deal, like, they're just scientists, right? Like, no, that's their job. They get peer-reviewed by hundreds and thousands of other scientists. And the thing about scientists and educated people is they like to point out when other people are wrong, right? Who doesn't like to point out when somebody else is wrong? So that's why our papers go through peer review. So the errors can be pointed out and be like, hey, I think this is wrong, you should fix this, I think it should be this value, or we need to discuss this because it doesn't seem right, or I didn't get the same results. So we need those kind of talks. So for people who are afraid to engage in those kind of talks, then they're not really scientists, you know? And anyway, so I hope you liked the video, and this is some random guy's plot. Peace.